Now that we have computed the range of a projectile along an incline, it would be interesting to know at what angle we should launch the projectile with respect to the incline, such that the projectile reaches furthest from the launch point along the incline. Here we are seeing this trajectory for this launch angle alpha. If we increase or reduce alpha, would the projectile attain a greater range? We know that when a projectile is launched from the ground and it lands back on the ground, the range is the maximum when the launch angle is 45 degrees. But will this hold when we launch it up an incline and measure the range along the incline? It is difficult to judge from this formula because we have a sine alpha and we have a cos of alpha plus beta, and we need to find the alpha for which R is maximized. Without going through the proof at this point, it turns out that we reach the maximum range when the launch angle alpha is 45 minus beta over 2. Just as an example, if the angle of inclination beta is 20 degrees, then when the launch angle alpha is 45 minus 20 over 2, which is 35, we get the maximum range. We get this maximum range R when the angle of launch alpha is 35 degrees. But this is true only for this configuration. So in this case, it is true only when beta is 20 degrees. You can see that alpha depends on beta here. If we change the angle of the incline, beta, then alpha would also correspondingly change for the maximum range condition. Also notice that this angle alpha is with respect to the incline. With respect to the ground, this angle would have been 20 plus 35, which is 55 degrees in this case. So this is the trajectory at 35. Let's see what would happen if we launch the projectile at 45 degrees with respect to the incline. So alpha would be 45. What would be the range if alpha is 45 degrees? And you should be keen on seeing the range at 45, since that would be the angle for the maximum range in a ground-to-ground case without the incline. And it goes higher, higher, and looks like it will exceed the maximum range. But no, it falls short. When the angle of the incline is 20 degrees, the launch angle of 35 with respect to the incline gives us the maximum range. Let's try this with another angle lower than 35 just as a confirmation. And this one, as expected, falls short. This is the trajectory when the launch angle is 25. So alpha is 25 and it falls short in terms of range as compared to the red trajectory for which the angle was 35. So when alpha is 45 minus beta over 2, we obtain the maximum range along an incline. Now let's try this out for a few more angles. We got 30, 31, 32, 33, 34, And you can see that as it approaches 35, the range gets to the maximum. And if we increase alpha further, then the range begins to reduce again. So when the projectile is launched from the ground and lands back on the ground, the maximum range occurs when the launch angle is 45 degrees. But when launched from an incline, the angle of the incline also plays a role in the maximum range. In this case, we have considered beta as 20 degrees and therefore alpha works out to 35 degrees. If you are interested in the mathematics of this, the proof can be obtained quite easily, and we'll do that next. Now this is for those of you who are interested in the derivation of the maximum range condition. We differentiate the range equation with respect to alpha. The constant terms are separated out, and we really have to differentiate sine alpha times cos of alpha plus beta with respect to alpha. And we set this to 0 to obtain the maximum. On differentiating, we get this form, which is cos A cos B minus sin A sin B, which is cos of A plus B. Here A is alpha and B is alpha plus beta. So we get cos of alpha plus beta is 0. So that must mean that 2 alpha plus beta is pi over 2. And from here, alpha is pi over 4 minus beta over 2. So in order to get a maximum range on an incline with an angle of inclination of beta, the launch angle with respect to the incline should be 45 minus beta over 2. When we launch a projectile on an incline having an angle of inclination of beta, the projectile lands furthest when the launch angle with respect to the incline, or alpha, is 45 minus beta over 2. We get to this conclusion by differentiating the range with respect to the launch angle alpha.